Okay, so for this first one, they say let f be the function defined by f of x equals e to the h of x, where h is a differentiable function. Which of the following is equivalent to the derivative of f with respect to x? Okay, so this is a chain rule question. Change this a little bit. Okay, so this is an exponential function. So the rules for exponential functions is rewrite the exponential function. Just rewrite the whole function exactly like it is. Take the derivative of the exponent, so h prime of x, and then technically you times by the ln of the base, but the ln of e is 1, so then that's it. So let's see. Okay, for number 2, they say let f of x equals x cubed and g of x equal x over x minus 1. If h is the function defined by h equals f of g, which of the following gives the correct expression for h prime of x? Okay. Okay. So it looks like all the answer choices, let's see, it's f of g of x for h prime of x. Okay, oh, I see how they're doing it. Okay, so if you look on the left-hand side, so this we gotta look at all the answer choices. So the left-hand side is if you thought of, since f is x cubed, another way to write h would be g of x cubed. Okay, so if you took the derivative of that, and you can tell because the left-hand side is only in terms of g, so it's not in terms of f. So that's what this is. So we'll do power rule. Keep the inside the same, subtract 1 from the exponent, and then times by the derivative of the inside. Okay, and then we can see that that's like number 3, so it looks like that might be the answer, or letter C. Okay, and then yeah, so it's got to be C, because then we can see g of x. We have g of x here, that just got substituted, and then g prime of x. So let's take the derivative of g of x just to make sure. Okay, so we'll do quotient rule. So derivative of the top is 1, and then so times the bottom, minus the top times derivative of the bottom. The top is x, derivative of the bottom is 1, so we don't have to write that. And then the bottom squared. Okay, these x's cancel. Oh, actually I didn't need to simplify because that's all they did for C. Okay, so we can see that's got to be answer choice C. Okay, so this next one is just giving a function and asking for the derivative. Okay, so we'll just take derivative of that. Okay, so overall we'll do the power rule. So bring the exponent out front. Leave everything the same in the first step. Subtract 1 from the exponent. Okay, so now we'll times by the derivative of the inside. Okay. So derivative of e to the 3x is 3e to the 3x And the derivative of sine 2x is 2 cosine 2x. And so that's it. C, so that should be B, I guess. Yeah. That's choice B. Okay, so the fact that first off they give you an equation with kind of a mixture of x's and y's, and they ask you for dy dx. So this is a implicit differentiation type question. Okay, with these, if you can solve for y, you could do that, and then you'd just be taking derivative like normal. But for this one, we can't really easily solve for y. So here we'll just kind of take the derivative, just start from left to right, and just kind of plug along. Okay, so we'll take the derivative of this first expression. And when I take derivative, I'm going to consider, like, we have to do product rule, and I'm going to kind of split those up like that. I'll put the 2 with the x. Kind of the same thing when we get to the point where we're doing product rule for these, I'll split them up like that. Okay, so let's do that. So let's take product rule. So derivative of the first is 2 times the second plus first times derivative of the second. So derivative of y squared, oops, what the heck, is 2y prime. Okay, then we'll do minus. We'll do the product rule for this second thingy. So derivative of the first, 6x times the second plus first times derivative of the second. Derivative of y is y prime. And then the right hand side, derivative of 6x is 6. Okay, then we can see we've got these two terms that have y prime in them, so we'll have to solve for those. Okay, the way that we're going to do it is get rid of parentheses. These two terms, this term and then this term that have a y prime in it, we have to, get those two terms on the same side of the equation, and then get everything else on the other side of the equation, and then we'll factor out the y prime and then divide by what's left over. Okay, so that's the plan. Okay, let's simplify this. Get rid of parentheses. Okay, that'll be 4xy. Distribute the negative. Okay, so I'm going to bring this term over, subtract that term, and then add this term. Okay, so the left-hand side will just have the two terms that have y prime. Got that. Okay. Now we'll factor out this y prime since it's common to both of those. Okay, and by now we could probably look at the answer choices and see which one's going to be right. All right, and then divide by this thing that was left over when we factored out the y prime. And we can do this. Divide by that. And that's what y prime is. Okay, so that's answer choice C. Okay, so this is another, this is a definite implicit. We actually can't solve this for y. So this we have to do implicit, but okay, so derivative on the left-hand side, derivative y is just y prime. Okay, derivative right-hand side, so right when I see that we have a log, and we're going to take a derivative, so I just make a fraction right away. The bottom of the fraction, you just rewrite the argument of the log, the whole thing. Just rewrite that on the bottom. And then the top of the fraction, we'll take the derivative of this. So the derivative of 3x is 3. Derivative of 4y is 4y prime. Okay, so now we have to actually solve this for y prime. So we got two y primes, these two y primes that we have to get together. So we'll multiply both sides by this denominator, distribute the y prime, and then do the same thing that we did in number 4. Kind of get all the terms with y prime on one side so we can factor it out, and then divide by what's left. Okay, so we'll basically just multiply both sides by this denominator. Cancel. And I'm going to distribute the y prime in this step also. Actually, I could have done that. I could have done that differently, but okay, that's okay. So we'll minus the 4y prime from the right-hand side. We'll minus that over to the left. So that'll stay the same. That'll stay the same. And we'll have this minus. Okay, then we'll factor out the y prime. And then divide. Okay, and then this will be the answer, and that looks like that is D. Okay, so this one, okay, so this is, so we got a function, or kind of an equation, I guess. It's got a mixture of x's and y's. We can't really solve for y. And then it's asking for the derivative, dy dx, at a point. Okay, so we're going to take the derivative of this implicitly. Right away, we're going to plug in 0 for x and 1 for y, everywhere we see an x and a y. And then we'll solve for y prime, solve for dy dx. Okay, so derivative, so we'll just start taking derivative of these terms. So derivative e to the y is y prime e to the y. Right, so you rewrite the function and then the derivative of the exponent. Minus, that'll be derivative of the exponent is 2y, y prime, and then just rewrite the function. Okay, right hand side, just regular derivative rules. So derivative of x is 1, and derivative of x cubed is 3x squared. Okay, so now right away, and I'll use this kind of notation just to get used to different things. So if you like put a little vertical line and then put something to the right, it means you're going to substitute that into the thing to the left. Okay, so let's do that. So y prime, and then we'll plug in 1 for y, so that's e to the 1, which is just e. And then 2 times y, that's just 2. And then this is another e, just e. E to the 1 squared is just e. And then y prime. And if you plug in 0 for x, that just goes away and that becomes 1. Okay, and then if we start solving this for y prime, then we can minus that over, so you have negative 2e equals negative. I'm going to put this ye, I'm going to make that ey. That's like a number, you know, e is a number, so it's like a number times y. The number should go first, but doesn't matter. Okay, then I'm going to times everything by a negative. And then divide by 2e. Oh, that should just be an e minus 1. Yeah, I forgot to, this y, I forgot to plug in 1 for that y. So we'll do it now. So when that y is 1, then it's really just that. Okay. Okay, and then that's b. Okay, next one, an increasing function f satisfies that and that. Which of the following statements about the inverse of f must be true? Okay, and then all of the answer choices are just talking about the derivative of the inverse at a certain x value equals something. Okay. Okay. So keep in mind a couple things. If f of 10 equals 5, that means that f inverse of 5 equals 10. Okay, and then we can use the formula. So here, if we want to find f prime at a certain x value, okay, and I'm going to leave that x value, oh, whoops, wait, sorry. Let me do this, sorry. This is really, so f inverse, and if we take the derivative of that at a certain x value, I'm going to leave that x value blank. This will be 1 all over the derivative of the regular function at some other x value. Okay, so this is just the formula for derivatives of inverses. Okay, so think about the only thing that's given is the derivative of the regular function at 10. So might as well, that's the only option we have. Okay, if we're going to use this x value for the regular function, then we have to use this y value as the x value of the inverse. And we can, oh, whoops, I meant, sorry. Sorry, looking at this. So if we're going to use this as the x value for the regular function here, then we'll use this 5 as the x value for the inverse. Okay, so hopefully people see how that works with the coordinates being different but coming from the same point. Okay, and then now they say this f prime of 10, that's 8. So this is really 1/8, and that's probably an answer choice. Yeah, so that's D. So we can see the derivative of f inverse at 5 is 1/8, and that's what this is. So. Okay, number 8, which of the following increasing functions f does the inverse at 20 equal 1/5? Okay, so before we look at the answer choices or do anything, okay, so we know the regular function. So if f, the derivative of f inverse at 20, 20, 1 all over the derivative of the regular function at some other x value, and if this has to equal 1, this equals 1/5. Okay, that means that the derivative has to equal 5. Oops. So the derivative at some, I'm going to call this a. The derivative at some x value equals 5. Right. Okay, so we so I have to figure out that x value, because this point, there's some point 20 comma a, we'll say, on the inverse. That means a comma 20 has to be on the regular function. Okay. Okay, so these questions are kind of strange because we just got to do it one at a time, I guess. Okay, so we one thing, we don't know the x value of the point, the x value on the regular function. We know the y value is 20. So we'll technically, so this is the way, okay, just keep in mind what we're doing. So they said the derivative of the inverse of some function at 20 equals 1/5. Okay, so using the formula, we realize the derivative of just the regular function at some x value equals 5. And that's what we're going to find. So this is the regular function. So the derivative of one of these functions equals 5 at a certain x value. So we have to figure that x value out for each one. And so to figure that x value out, so if f of x equals x plus 5, okay, and we know that there's a point a comma 20. So you can do, that means f at a equals a plus 5, and this is for answer choice A, equals a plus 5, and then that equals 20. So if you plug in a, you get 20. That means in that case a would be 15. Okay, so for this first answer choice, you'd have a point 15 comma 20. And then we see, does the derivative at 15, does that equal 5? No, this derivative equals 1. If you take the derivative of this function, it always equals 1. So I could have even skipped that, but I was just doing that for practice. So definitely not that one. Okay, so go on the next one. So for B, so do f at a. And then that has to equal 20. Okay, the 20s cancel, so you get a cubed plus 5a equals 0. That means, okay, so just some algebra. Oops. So factor out the a, you get a squared plus 5 equals 0, so that means a has to be 0. Okay, so for this answer choice, the point is 0 comma 20. Since a is 0. Alright, so we'll take the derivative. This is all for answer choice B also. Okay, so derivative of that function is 3x squared plus 5. If you plug in 0 for this, f prime at 0, this equals 5, so that finally worked. Alright, these questions, I don't like these questions. I think they're, I don't know. kind of strange. Like, they're fine, you know. So this definitely would not be a test question. This is a question you're supposed to learn from. And so just learning how inverse derivatives of inverses work. I guess it's a good question to learn from. It's just tedious and time consuming, I guess. But, okay, let f and g be inverse functions that are differentiable for all x. If f of negative 5 equals 7 and g prime is 7 equals 3, which of the following statements must be false? Okay, and all the statements are the derivative of f at different x values. All right. Okay, so let's start with this g prime of 7 equals 3. Okay, so that means g prime of 7, using the inverse formula, is 1 all over f prime. So if you think about it, you have a point. If you look at this, you have this point on f. On f, you have a point negative 5 comma 7. That means on g, since they're inverses, there's a point 7 comma negative 5. Okay, and so that's what we'll use, f of negative 5. Okay, and then this equals 3. Since that equals 3, that means f prime of negative 5 has to equal 1/3. Okay, so when they say which of the following must be false, we know it's not number 2, because number 2 is true. Okay, and sorry, and I was just kind of thinking about, so there's a bit of a complicated reason, and next chapter, once we start talking about max and mins, it'll make more sense of why the first one has to be false. But we won't worry about that for now. If you could even just get the fact that statement 2 is true, then that's the most important thing. So technically the answer is A, but most important thing for this question, you know, since we're just learning from these, is really just realizing that this is true. That's the most important thing, really, because of that formula for derivatives of inverses. Okay, so this one, this is just memorizing the derivative of inverse trig functions. Okay, so we know the top goes the derivative of the argument, so derivative of 3x is 3. And the bottom is the argument squared, so 3x squared. And then just plus 1. And that's it. Okay, so another one that's just memorizing, and just memorizing that it's C. Okay, this one, realizing that this is one of the definitions of derivative, and this is derivative of f. This is the definition of derivative of f at root 3. And so that's what we'll do. So for this one, we'll take derivative of tan. So actually, I'm going to write this a different way. Okay, so f prime of x is just 1 over x squared plus 1. And then we realize that all this is asking for the derivative of root 3. All over root 3 squared is just 3. And that's 1/4. Okay, which of the following does not require the use of the chain rule to find dy dx? Okay, it looks like C is the only one. So A requires chain rule because you have something inside of a trig function other than x. Here you have something being raised to an exponent other than x, so you have chain rules for the y squared and y to the fifth. And then for D, you have again, you have a trig function that has something other than x, so then that'll require chain rule. So C is the only one that won't require chain rule. Okay, next one, they give a table of f and f prime at a couple different x values, and they give you the value at those x values. Okay, table above gives selected values for a differentiable and increasing function f and its derivative. Let g be the increasing function given by g equals f plus f of x plus f of 2x, where g of 3 equals f of 3 plus f of 6, which equals 9. Okay, which of the following describes a correct process for finding g inverse, derivative g inverse at 9? Okay, so first I think is using the formula. Okay, so inverse of g, if we take the derivative at x. Okay, so just using the formula for now is 1 all over g at some y value, g prime at some y value. Okay. So the derivative of the inverse at some x value is the reciprocal of the regular function at the corresponding y value. Okay, and then we're going to, if the x value is here, the x value is 9, if we plug in 9, g inverse derivative at 9. Okay, and so there's a point, you can see there's a point 3 comma 9 on g. So on g there's a point 3 comma 9. That means on g inverse there's a point 9 comma 3. So we can see that the x value on the inverse was 9. So that means the y value we're going to use here is 3. I think that'll be the first thing to do. Okay, so that's either answer choice A or B. Okay, and then now we have to find g prime at 3, and so we'll take the derivative of this g, and so that's what they did for answer choice A, took the derivative. And just notice this 2, you'll get a 2 coming out of here, because when you take derivative in the chain rule, derivative of 2x is 2, and so that's why you get a 2 on the outside. Okay, so that'll be answer choice A. Okay, and did I not even use that chart? That's weird. That's very weird. Yeah, I think these questions have a lot of mistakes in them, to be honest. Yeah, we didn't even use that at all. Oh, there's x at 3, y at 3. Yeah, we just didn't even need it, though. Alright, that's weird. Okay, which of the following could be used to find the slope of the line tangent to the curve of that? That could be used to find the slope of the tangent to the curve. Okay. Okay, and then all the answer choices, just look like some kind of derivatives. Really just the derivative of this equation. Okay, so let's just do that. So we'll just take the derivative of this whole equation here. Okay, so we'll start off with taking the derivative of this tan inverse. So derivative of tan inverse. The top is the derivative of this angle, this argument. So derivative of x is 1, and then derivative of 2y is 2y prime, and derivative of 2 is 0. And then you all do that this whole thing gets squared, and then plus 1. Okay, so you can see this thing gets squared plus 1, and then the derivative of this goes on the top. Okay, and then that equals, so derivative of 2x, or derivative of, so start taking the derivative of the right-hand side. So derivative of x squared is 2x. Derivative of 3y is 3y prime. And then the derivative of the rest is just 0, because here there's no x's, it's just tan inverse of 2, so that's just equals some number. And then 1 minus 1, that's some number, so these just go away when you take derivative. So this is the only derivative, and that looks like that is either C or D. What's the difference? Oh, it's got to be C. D doesn't have a square, so it should have a square. Okay. Okay, let f be the function given by that on the closed interval. What's the instantaneous rate of change of f prime at x equals 1? Okay, so this is kind of a tricky question with the wording. So they don't want if they wanted the instantaneous rate of change of f, they don't ask for f, they ask for instantaneous rate of change of f prime. But whenever they want the instantaneous rate of change of something, you take the derivative of that thing. So if we want to find the instantaneous rate of change of f prime, we have to take the derivative of f prime, which is really f double prime. And so that's what we want. This question is really asking, what's f double prime at 1? Okay, so that's what we have to find. Okay, so let's find the second derivative of f. 6x squared minus 10x plus 8. Oops, that's the first derivative. Oops. Erase that. Okay, so now we'll take second derivative. Okay, and then just plug in 1. Okay, and that's it. Okay, next one asks for, just gives you a function in terms of x and asks you for second derivative. Okay, so first off, let's just start by getting first derivative. So derivative of y is y prime, right-hand side. So you just rewrite the function, since it's an exponential, and then times by the derivative of the exponent. So the derivative of that exponent is just 3x squared. I'll put that first. Okay, so now we'll take second derivative. So for second derivative, we'll have to do product rule. Okay, and I'll consider that as one thing, and that as the other. Okay, derivative of the first thing is 6x times the second thing plus the first thing times derivative of the second thing. So we've already taken the derivative of that. That's just 3x squared e to the x cubed. And then we'll look at answer choices to... And then notice how none of the answer choices... Oh, whoops. Wait, what am I talking about? Let's factor this out. Here, let's simplify this and factor this, actually. factor out? Oh, they only factor out an e to the x cubed. Okay. And so we can see it's going to be d, right? When we factor out that e to the x cubed, we're going to get a 9x to the fourth, because there ended up being those 2, 3 to the, yeah, you know. Okay, so it's got to be d. Okay, last one here. Let f be the function given by that. Which of the following statements is true for y equals f of x? Key. All right, so all the answer choices. The first one just talks about the second derivative of the function. Part B is saying the third derivative equals the first derivative. Answer choice C is saying the fourth derivative equals the first derivative times the third derivative. And answer choice D is saying the function minus the fourth derivative equals 3x. All right, so no way that we're going to know which one's which unless we just kind of, actually there's a couple ways, but we'll just start taking derivative. Okay, so yeah, anywhere, you know, y equals f of x, so when they say y double prime, they mean f double prime, same thing. Okay, so let's start taking derivatives. So f prime of x equals, so derivative sign is cosine, and then derivative e to the negative x is negative e to the negative x, and derivative 3x is 3. All right, and that doesn't really help with anything. Okay, so let's take derivative of that. Derivative cosine is negative sine. Derivative of e to the negative x is negative e to the x, so that'll make that a positive. And that's it. Okay, so we can eliminate a, because it should be, this just says sine x plus e to the negative x, but it should be negative sine x plus e to the negative x. Okay, so it's not that one. Okay, so the other ones at least involve the third derivative. So let's find the third derivative of this. Okay, derivative of negative sine is negative cosine. And then we know this is e to the negative x. Okay, so they're saying for B, they're saying does the third derivative equal the first derivative? Here's the third derivative. It definitely doesn't equal the third derivative. Okay, so we can eliminate that. Okay, the last two answer choices deal with the fourth derivative, so let's find that. And we could use this notation. Instead of doing slash marks, you can write a number, and that means fourth derivative. Okay, derivative of cosine is negative sine, so that negative cancels to be just sine. And then plus, change sign also. Okay, so let's see. Let's try something about C doesn't make sense to me, but maybe that's it. Maybe that'll end up being it. But let's try answer choice D, see if that works. So this is saying the original function minus the fourth derivative equals 3x. Okay, so here's the original function. If you minus the fourth derivative, you do get 3x, because when you minus the fourth derivative, this sign cancels out with that sign. E to the minus x cancels out with that e to the minus x, and you're just left with 3x, so that has to be it. Okay, so that's everything.